Welcome back. Let's continue to learn how to incorporate audio into your Raspberry Pi and Python projects. In this video, we'll continue to look at how to incorporate audio functionality into your projects. In particular, we'll be walking through the various audio output hardware options as well as looking at audio input device options. The Raspberry Pi Model 3B from your kit includes a 3.5mm jack that can be used to output audio signals. This type of connection is commonly referred to as a headphone jack, as it's normally used to connect headphones to a device. This port is located between the Ethernet and HDMI connectors on the Pi, and I have circled it here in red for you. The Pi can also output audio using the HDMI cable. This can be useful if you have a TV or a computer monitor with built-in speakers and an HDMI connection. Running audio over the HDMI connection allows you to run both audio and video in a single cable, eliminating the need for a separate dedicated audio cable. You can switch between these two outputs by right-clicking on the audio icon in the upper right menu bar and selecting the option that you'd like. So analog, that selection will output audio on the 3.5mm audio jack on the side of the Pi. If you select HDMI, then that will output audio on the HDMI connector so it can be received by an HDMI connected device with speakers. The output volume level can be adjusted by left-clicking the audio icon and adjusting the slider up and down. The top of the slider is 100% volume and the bottom is 0%. There's also a mute checkbox that will automatically make the output level 0%. If you're ever having trouble with the sound not coming out of your Pi when you expect it to, okay, these are the settings you're going to check in this order. First, you're going to make sure that mute is not checked. Second, you want to make sure your volume slider is up there high, probably near 100%. You want to make sure your output device matches your connected device. So analog for a device connected to the 3.5mm audio jack and HDMI for audio capable devices connected to the HDMI port. So if you have this, if you have your Pi connected to a television per se with speakers, you want to make sure the HDMI port is selected. Also, don't assume that all HDMI devices have speakers, right? So HDMI connected TVs will have internal speakers, but most HDMI computer monitors don't have internal speakers. So when in doubt, check the specifications of the device to determine its audio capabilities and required connections. One way to get better quality output audio from a Raspberry Pi is to use an external USB sound card. These devices have their own devoted circuitry to create audio signals, which will often result in higher quality audio. Some of the drawbacks related to these types of devices, though, are driver and software support. Just because you can plug a USB device into your Pi doesn't mean the Raspberry Pi operating system will know how to talk to that device. A list of supported devices and any known issues with their driver support can be found at the website address you see here, and that should be all on one line. If you plan to attempt to use an external USB audio device with your Pi, you need to make sure to consult this list to ensure that the hardware is supported and that you fully understand the software modifications that will be required to make your device work. Don't just look at this picture and go buy one. Make sure you check that list. The USB audio adapter included in your kit uses the General Plus chipset and driver. While this device is not called out specifically in the list of supported devices, this audio adapter adheres to USB audio standards, so it falls under the class-compliant USB sound cards at the bottom of the list. Using a device that conforms to USB audio standards will ensure the best possible driver and software support, as support for this type of audio device is built directly into the Raspberry Pi operating system and other Linux distributions. A USB audio device should only be plugged into a Raspberry Pi when the Pi is powered off. This will allow the Pi to detect the audio device at boot and load any necessary drivers so the device can be used for audio output once the Pi is fully booted up. If an external USB audio device is used, additional options will appear when right-clicking on the audio icon in the upper right menu bar. If your USB audio device supports audio output, then selecting USB audio device from the list will output audio using that device and not analog or HDMI. If your device does not support output audio, then this option will not be present on the list. Clicking on USB device settings will allow you to configure audio settings related to the USB audio device, and these settings will be covered later in the section on USB audio settings, input settings. You've previously learned about sending audio out through that 3.5 millimeter jack in HDMI, but there's another method available for getting audio out of a GPIO pin. The left and right audio channels coming out of the 3.5 millimeter jack are actually connected to GPIO 40 and GPIO 45. And I know you've never heard of GPIO pins with that high of a number, right? Because these aren't actually user accessible pins. These pins can only be used internally by the board to send audio out of the 3.5 millimeter jack. The Pi uses some additional GPIO modes named ALT0 and ALT5 for playing right and left audio channels. ALT0 for the right, ALT5 for the left. Since you have so much control over the GPIO pins on the Raspberry Pi, you can actually use software and connect GPIO pins from your breadboard to the ALT0 and ALT5 channels. That way, whenever audio is played through the 3.5 millimeter audio jack, it will also be played through the GPIO pin. Now, there are some limitations on which GPIO pins you can use for this type of operation, as you see in this table. But setting the mode for GPIO 18 to ALT5, you can obtain the left channel of any audio played through the 3.5 millimeter jack. And this can be done by using the following wiring Pi command on the CLI that you see here. Let's switch gears a bit from audio output hardware to audio input hardware. The Raspberry Pi does not have built-in capability to allow for audio input like a microphone. If desired, this functionality can be added though by using that USB audio device. Most USB audio devices will have a 3.5 millimeter output or a headphone jack, but some will also have another 3.5 millimeter input or microphone jack that can be used to record audio input. While audio output level can be controlled by the volume slider, microphone input level can also be adjusted by right-clicking on the audio icon in the upper right menu bar and selecting USB device settings from the menu. Using the drop-down menu at the top of the settings window, select USB audio device or ALSA mixer, and this will ensure that you're looking at the settings for your USB audio device. Initially, there will not be any settings available, as the settings that are available are configured in the Select Controls area. After clicking on the Select Controls button, you'll be able to select which audio controls you'd like to view in the main panel by adding a checkbox next to each control. The speaker and microphone settings are not needed, as they just set the output volume level for those 3.5 millimeter ports on the USB audio device, and that setting can be accessed in the top menu bar of your desktop. Clicking the box next to microphone capture and then closing the window with the close button will allow this control, though, to be accessed in the main control window. The Capture tab will now contain the microphone capture level slider, and the position of this slider will determine how much gain will be applied to the signal coming in from the microphone when being recorded. Louder sounds coming into the microphone will need a lower capture level on the slider, while quieter sounds requiring more gain will need a higher capture level on the slider to ensure they get captured with good quality. The red button below the slider will mute the microphone input, disabling all input from the microphone. And when the button is red, the microphone is live and can be recorded. When the button is light gray, the microphone input is muted and no sound can be recorded. The mute function can be toggled by clicking on this button. Okay, before you move on to the next video, let's take a few moments and to review the concepts we just discussed in the last two videos. Different size speakers require different levels of amplitude. An amplifier can take a small signal and make it much larger and appropriate for driving larger speakers. Amplifier gain is the amount of amplification, and some small amplifiers like the one in your kit can be adjusted using the potentiometer on the circuit board of the amplifier. Distortion occurs when the driver signal is too large for the connected speaker. So slight distortion just means the sound will be degraded. Heavier distortion, though, can damage your speaker. Your kit includes a PAM 8302 amplifier with input power from 2 volts to 5.5 volts. When attaching it to a speaker, you'll want to be sure the speaker's impedance range is between 4 and 8 ohms. And then in this video, we switch gears to look at audio output and input hardware. Your Pi includes a 3.4mm headphone jack that can be used to output audio signals. If you're planning on attaching your Pi to a TV or computer monitor that has built-in speakers, audio output is also available using the HDMI connection. And remember, most computer monitors do not have built-in speakers. Your kit does include a USB audio adapter, but if you have another external USB audio device available, be sure to check the list of compatible options to make sure there's driver support available through the Pi. We also walk through the option of using GPIO pins for audio output. Now, in terms of audio input, the Pi doesn't have built-in capability for something like a microphone, and the USB audio device in your kit will come in handy there. Okay, go ahead and move on to the next video for this lesson, where we'll look at audio software commands as well as the OS module.